So today's lesson we're talking about the electrical engineer practice. So they are the question and answers. Describe the effect of changing the symmetry setting from the low to high. So regarding the electrical engineer practice, we're talking about the emergency system. So they are the emergency system got the interactive based power supply or battery power UPS, standby emergency alternator. Those are the parts of the emergency system. So they are part of the emergency system. In the meantime, another emergency system is fire protection emergency lighting. So interactive power supply UPS, there are two kinds of UPS, offline UPS and online UPS. Online UPS include the changeover switch. So it switches to the main power to UPS power, and online UPS is the emergency supply. The emergency supply is connected when the main power off only. So this is connected to the emergency load supply. So this is the connection of the UPS system. So this is a connection of the UPS system, online UPS connection. This is voltage regulator, filter, battery charger, inverter system connected to load. So that the main to the battery changeover switch or the battery to main changeover time is typically the 3 to 8 milliseconds. So during the test time, the changeover is not provided. So this is also the transfer switch. When the load failure is sensed and transfer switch set connected to the main power load. And then also the online UPS system is here static bypass switch. This is you call this rectifier connected to the battery when the main power is on, and that also when the main power off, the power passing through the inverter and connected to load. So the normal supply system, the current flow to the rectifier to battery charging. And in the meantime, from the inverter connected to load and static bypass switch to load. So this is the connection of the main power transfer system. When the main power free, the switch connected to battery and inverter connected to the load. So this type of the UPS is a system that remains on the battery when the main AC is present or not. When the main AC is present, it provides the power to the rectifier, which charge the battery. Simultaneously, provide the DC supply to the inverter that provide the main frequency and the voltage supply to the load. When the main power fails, the battery supply the load through the inverter. The system may be equipped with the switching of the non-essential load when main power is failed. So this is the connection of the system UPS system. So that we also have to explain the principle operation of online UPS. So this is the diagram of the online UPS system. This is main power, rectifier, battery bank, inverter, and load static bypass switch. So this transfer switch is connected to the selection mode. When the online or offline is embedded, so that kind of selection mode is included. So that when to set the offline, this is the monitor the system of main power supply. So that when the main power supply situation monitor and the main supply is on, so the transfer switch is on. The simplified block diagram on this system is showing a figure. In this type UPS, the system always remains on the battery whether main AC is present or not. When the main AC is present, it provides power to the rectifier, which charge to the battery and simultaneously provide to the DC supply. So to the inverter, when the main AC supply is not present, The battery provides the DC supply to the inverter. The changeover time is online UPS is 0 because the inverter session always on. Online UPS are the bulky and are manufactured in a high capacity rating and used for the large and a very sensitive application like the computer server and medical supply. Because of the computer server and medical supply, we might use the online UPS system. So the UPS system largely use the battery system. So the electrical energy charge that are chemical energy. The charging die electrical energy is converted to the chemical energy, and discharging die chemical energy converted to the electrical energy. So this is the charger is a connected circuit. Electrochemical cell is a chemicals are recharged. So this is for the primary cell. It cannot be recharged. This is can be recharged a secondary cell, cannot be recharged a primary cell. So here we need a connection of basic principle of the chemical bridge, chemical cell. This is anode, this is solvent, and this is cathode, and this is the current flow to the from here to here. So the solution is this solution containing the electrode plus iron. This is copper is an anode is an electrode. Anode electrode copper deposit. They are solvent bridge, and this is the copper, and this is cathode electrode. So this is the charging principle and the chemicals are equivalent diagram. So when the charging die, there will be electrovoltage changing, included in this charging system. So the electrolyte utilized as the liquids are conduct the two electrode. So this is the electrolyte. The time given for the hydros are particles are bagging. So this is the electrolysis system. This is the hydrogen barbels are bearing. The time given for the hydrogen bearing are bearing. On the cathode is this process is the electrolysis. And the longest cell life is a lithium. The longest cell life. Open circuits are body on the lithium magnetic cell. Lithium magnetic cell is a 3.8 volt. Open circuit transformer body on the lead acid cell is a 2.105 volt. So the capacity is 60 to 75 watt hour per kilogram. The operation temperature is minus 40 to the plus 60 degrees centigrade. So this is the battery charging and the discharging the diagram. When the battery charging, so this is charger capacity and this is discharging system. You can follow like this. This is the battery charging and discharging system. So the battery capacity is measured by the ampere hour. So we have to calculate the continuous current that battery with the 300 ampere hour rating can deliver on 10 hour discharge. So this is the current equal to ampere hour divided by time. So 300 ampere hour divided by time 10 hours. So you got the 30 ampere. So this is the battery charging and discharging diagram. So this problem, we need to calculate 4 alkylene mechanism D cell, which is over circuit voltage 1.5 volt. They are connected in parallel to the supply 3 ohm load. Ignoring internal resistance, we need to calculate the open circuit voltage or the battery load current and current supplied by the E cell. So these connectors they are series connection. So all the cell E1, E2, E3 can be added together, and all the resistance can be added together. Internal resistance can be added, but the current is the same current. Parallel connection, so all the voltage are the same, but the resistance 1 by RD is 1 by R1 plus 1 by R2 plus 1 by R3. So the current I1 is ID is I1 plus I2 plus I3. So this is the way. So all the 4 battery cells are connected in parallel. So this is connected in parallel here. To the supply voltage is 1 by 5 volt and connected to the 3 ohm supply. Internal resistance is 0 or the resistance. So the ID is to V by R, 1 by 5 divided by 3, you got a 0.5 ampere. So that all the I1, I2, I3, I4, they are the same. They are the 0.5 ampere. So that they are 4 times the battery is a 0.5 ampere. So that each battery supply there, 0.5 divided by 4, you got a 0.125 ampere. And all the resistance value 1 by RDA, 1 by 0.04 plus 1 by R04 plus 1 by 0.04 plus 1 by 0.04. So 1 by RD is 4 by 0.04. Therefore, the RD equal to 0.01 we got. Then we can calculate the E equal to I plus capital R plus small r. So 1 by 5 equal to I multiply 3 plus 0.01. Then you got the I is 0.498 MVR. So each battery, so divided by 4, you got the 0.124. This is when the each battery got this in our 0.010, we can calculate the battery voltage by this way. So the arrangement of battery in the emergency system. So this is the central batteries are back, and the main inverter, and this is a changeover switch connected to power line and connected to the load like this. So this is the when the main power line is sensed by the same changeover switch, the changeover switch switch the power to the main power system. The cell connected system is all the battery system. They are individual units are included the system and the battery. Cited the two advantages and the two disadvantages of the central battery system over a cell connected system to provide electrical power to angles and lighting during the time of the main power failure. So the advantage is that once a centralized battery provides for the reducer maintenance time and by concentrating the battery source in the one space. In some installation, central system can be less expensive to install. This advantage is that all the cabling between the battery and the luminaires must be in the fire rated. They must be the MIMS or the PVCS3 conduit, redox cable, etc. Failure of the battery means a total failure of the whole system. Battery charging time, these are precautions which must be observed when the charging is standby battery. So in this case, we had to install a safety plug. Safety plug is fitted to the cell, must be firmly tied in the place at all times during the charging. Electrolyte level must be maintained and electrolyte temperature should not be allowed to reach the 45 degrees centigrade. When the boost or the supplementary change has been completed, the battery must be returned to the flow condition to provide the damage in the cell. So this is for the connection of the standby portable alternator system. The alternator is driven by the diesel engine, petrol engine, and the gas turbine system. They can be utilized to drive the alternator system. And then the next one is another emergency system include the ionization smoke detector system. This is the electrical power source, and this is the positive and negative side, the positive electrode, and this is for the negative electrode. When the main power is failure, so that will be the alpha. When the smoke comes in, so this is the alpha particles are full between the chamber. Therefore, the electrical current conducted from the electric positive and negative charge, and then this will sound the alarm. So this is for the ionization chamber contain the immediate amount of the radioactive materials, so American under the normal condition. Airs connected in the ionization chamber is ionized, and the beacons are connected, allowing the simultaneous current to flow from the battery through the chamber. So through the detection circuit and back to the battery. When the smoke enters the chamber, it disrupts the supply, the current flow, and activates the alarm. Ionization smoke detector is a more response to the flaming the fire. So this is for the photoelectric smoke detector connection system here. So this is a photo cell. The light source is a send. For the light source send the any smoke, the electrical current flow. Then it sound the alarm. The photoelectric smoke detector use a principal scatter or the reflected light to indicate the presence of the visible smoke. In the absence of the smoke, the chamber is dark and the light change across the chamber and there is a receipt in the light, then on the flare side. So when the smoke is present in the chamber, a photo cell located at the right angle to the light source is sense and scatter, and the smoke particle at the starting level of the illumination to trigger the lamp. So therefore, the normally this cycle is full illumination. So when the smoke comes here, the full illumination is scattered, and the illumination level will be reduced. Because of the reducing the illumination level, this photo cell light catcher we indicate as a signal, and this signal we sound alarm. So this is what the photo says included. So we also utilize as a fixed temperature detector. Fixed temperature detector is a measure explicit detector. So it measures the temperature around it, and then this is the type of the heat data system. So they include as an operation based on the temperature of the heat. So that can be we have to be used the appropriate requirement system. That can be when we are installing the smoke detector system, we have to know about the scope. We have to know about the type of system. We have to design a appropriate smoke alarm system. We have to provide a smoke detection system, and we have to provide a smoke detection for the smoke control and the building occupant. Depending on the building occupant and the system monitoring, we have to provide the appropriate thing. So the next one is the emergency lighting system. Evacuation system must be installed in all the buildings that are not a single domestic resident. So the regulatory requirement is a building code of the Australia. It mentioned about this regulatory requirement. ES 2293 part 1 and 2 is mentioned about the regulatory requirement. So the emergency evacuation lighting must be provided for the building. So the building system configuration include the central battery system and the cell container system. The central battery system is that we must utilize a fire rated cable, MIMS cable, and also dedicated battery load must be provided. Cell container system, we also utilize individual luminaires are equipped with a cell container battery and charger. Each luminaire is independent of the all other parts in the evacuation system. The advantage are that they are very flexible, simple monitoring of the individual area. The egress luminaires are simply connected to local lighting circuit, and no specialized wiring is required. And the multiple battery provide the assurance against the total failure of the system. But disadvantage are that they are high cost and multiple battery to check and maintain. So this is the higher replacement of the battery charge. Here is the evacuation luminaire. So there are the two kinds of the system, maintenance luminaire and non-maintenance luminaires. Maintenance luminaires are the powered by the rechargeable battery, the compact and probation and the on switch added to main battery charging. Non-container luminaires are the luminaire is off during the normal supply period, activate when supply fail, and the lamps are the provide the efficient energy efficient type. They must have the energy efficient type. So this is the diagram symbol of the normal, and this is the emergency. So this is the sustainer luminaires are the two separate lengths are utilized. One for the normal supply, the other for the emergency supply. This is normal supply, this is the emergency supply system. Requirement of the BCA building code of Australia, there must be the egress lighting. They will see the white data on the green background. They will have to provide the position of AC within 2 meters of the every change of the direction. We must provide it and must be in the position when they can see from the any point. So this is for the connection. Every change of the direction, we have to provide the emergency AC signboard must be located. So appropriate illumination source evacuation light is the 0.2 lux. Battery used in the emergency system, emergency lighting will be the nickel cadmium and the lead acid and the NiOH period. Testings we have to provide every 6 months during circuit. They must be tested and removal of the power supply for the area and the running on the battery for the 90 minutes include important and the replacement unit which fail to operate the minimum time. So this is the testing unit. So in this case, we also provide a specific location. Emergency escape luminaires are required within 2 meters of the approach side of the eastern doorway and requiring the AC side. And within 2 meters of the intersection of the center lines or the intersecting corridors, within 2 meters of the intersection of the center line at each chain of the direction, and within 2 meters of any chain of flow level on the low side. So this is the any chain of direction, any intersection, we must provide the low luminaire. And also low side, high side, and we must provide, and from the doorway in 2 meters, we must provide the emergency cell. So they are the, we have to utilize the battery. This is the specification, quadruple A. So So the 8.3 millimeter and 42.5 millimeter. A is a 10.5 millimeter to 4.5 millimeter. The dimension. A is a 14.5 millimeter multiplied by 50.6 millimeter. C is a 26.2 millimeter multiplied by 50 millimeter. Theta is a 34.2 millimeter multiplied by 61.5. 9 is a 8.5 millimeter multiplied by 26.5 millimeter. This is the dimension of the classification of the battery. So there will be the electrochemical cell series, potassium, calcium, sodium, magnesium. This is the electromagnetic cell. So that when the metal activity increase, there are, this is the from here to here, the upward is a metal activity increase, downward is a metal activity decrease. So this is the dry cell, or primary cell, a dry cell. So this is the zinc carbon and the carbon and zinc combination, this electrolyte. So zinc is a negative, carbon is a positive. So they can be the 2 to 3 year life, voltage is a 1.5 to the 1.755 volt. Operation temperature is a -5 to 55 degrees centigrade. Electrolyte is ammonia and chloride is utilized. Alkaline batteries are the zinc is an anode, magnesium dioxide cathode. The electrolyte is the potassium and hydroxide. So they got a 3 to 5 years of cell life. Each got is a 1.55 volt, and they can produce a 163 watt-hour per kilogram and operating temperature -22 plus 60 degrees centigrade. And lithium battery, the cathode is a manganese, anode is a lithium. The electrolyte will be the lithium peroxide, chloride is a inappropriate carbonate. Cell life is a 5 to 7 year voltage is a 1.5 volt, operating temperature is -20 to 55 degrees centigrade. Secondary cell can be rechargeable. The lead acid cell, alkaline, nickel family, lithium and sodium ion. Lithium is low is the light is a lithium cobalt or iron phosphate or manganese oxide utilized. They are also utilize the carbon. Electrolyte is orange carbonate or cell voltage 3.5 volt and circuit 5,000 to 2,000 time we can utilize. So these are the connection of the lead acid cell. Anode is a sponge lead, cathode is a lead peroxide, electrolyte is sulfuric acid and water. So this is electrolyte are the combination of the H2SO4 and H2O. Charging time, the electrical energy converted to chemical energy. Discharge time, chemical energy converted to the electrical energy. Cell voltage 2.105 volt and operating temperature is -42 plus 60 degrees centigrade. Nickel cadmium battery is a nickel cat. So nickel is a hydroxide. We use a cathode and metallic cadmium anode. Potassium hydroxide is we use as an electrolyte. The watt-hour kilogram 40 to 60, and the cell voltage is a 1.2 volt, and we utilize a 2,000 cycle. Nickel metal hydroxide is an NiMH. So nickel hydroxide is utilized as an electrode, and hydrogen are the based on the electrode. So the potassium hydroxide is utilized as an electrolyte. Cell voltage 1.2 volt, and we can utilize the 500 to 1,000 cycle. So the next will be the remote area power supply RAPS. A remote area power supply system is an autonomous electricity supply system that rely on the one or the more energy sources, usually in conjunction with the battery and the power conditioning equipment. So this is for the photovoltaic module. We utilize solar and the sun energy. So this is the solar cell. We charge the stabilizer and connect to inverter, connect to load. So the from the charger to connect to battery charger, and then we are connected to battery. So this is the configuration of the solar cell system. So here is a wind energy system. Winds are power supply system. Wind power supply is a turbine blade, and this is the generator AC to Z. We connect to conditioner and connect to load. Also, we utilize a micro hydro generator system when the water flowing, water turbines are driving the generator on. This is the horizontal type, this is the vertical type generator. So the diesel or the petrol generator are also utilized. So the selecting the standby alternator is we have to utilize the power. 0.8 is a power factor, 0.8 is a common, and brushless machine and the automatic voltage regulators are required. Engine protection we need to provide. So in this case, a petrol-driven engine machine should not be driven at the less than the one load for the long period. Starting, stopping time, all must be turned off. Or the Austrian standard, we had to apply the ES3000 section 713. Generation system must be followed. Engine-driven system included the generator set. We also include a standalone system, grid-connected inverter, and a battery system. So this is section 7.3. In this case, A is a selection and installation, B is a control, C is isolation, D is overcurrent protection, E adding, and the F is connected electrical equipment, G is a connection to the electrical installation. This is for the section 7.3 of the AS3000. It mentioned about the detailed installation of the emergency alternator system. So in this case, the ASNS 5033-2005 rules are mentioned about the installation of photovoltaic PV array. AS4 777-2005 edition is mentioned about the grid connection of the electrical energy system inverter. And also the service and installation rule on New South Wales, section 8 mentioned about the connection of the emergency system. In the meantime, ASNS 3010.1 electrical installation. This is a supply by generator set part 2. Also international conversions are engine driven side. Those are the rule and regulation that the installation of the emergency system must follow. In the meantime, we are talking about the generators parallel operation. Now, when you are do the generator parallel operation, we have to do the site electrical drawing. We have to set the protection setting. We provide the earthing system. We need to determine the size of the generator, and then we have to propose an installation date. So international connection protection are included over and under protection relay. Automatic synchronization unit must be included. Overcurrent output protection must be included, and supervised battery supply must be included. At the time of the abnormal condition, reverse power protection and the loss of the excitation protection in the island, they must be provided. In the meantime, negative frequency sequence must be sensed, and rotor spark must be sent, and differential system must be provided, and also thermal overload system must be provided. This is the kind of agenda. So here is the solar cells diagram. This is for the solar cell. This is solar cells connection diagram. This is the solar battery, solar charger controller diagram. So this is the solar charger controller diagram. In the meantime, we also need to provide this illumination control. Illumination control is utilized for the visual comfort of the person and the performance and working to complete the tasks. So that in this case, the illuminant is the appropriate illumination must be provided for the system. So this is today's we are talking about the emergency system, battery system, and standby power supply system. So next week we continue the illumination control. That's for the electrical engineer practice. Then we're talking about the electrical engineer trade practice. What's your practice? So electrical engineer workshop practice, we provide this. This is for the electrical trade. The previous one is a Bachelor of Applied Engineering. So solids are fixing exposed system. Fixing to the solid brick and brown on the concrete. So when you fix the fixing, it must be the strong enough for the application and insert the correct type and the size of the drill and the screw. They are suitable for the fixing to the floor or the masonry ceiling. So that the plug must be the plastic or the fiber plug can be utilized. They usually the ordinary wood screw, fixes the diameter, and then must be weight, and then follow the manufacturer's recommendation must be followed. In the meantime, regarding the drill side and the left side of the screw must be appropriate. And that area, in this case, we cannot install the no steel or materials can corrode. So we cannot use a steel or any material can be corrode, must not be installed in the dam area. So this is the drainage of masonry type. In this case, drainage masonry we have to drain the hole to be drained in the brick block or the concrete before the plug can be inserted. So this is where we have to drain the hole and then check the conceal electric wiring and pipe. Then we have to, after we drain, we have to blow out the waste. So use a blower or the compressed air to remove the dust. We have to use a safety glass sheet, ear muff, or respirator must be worn. The tile of the wall can be the brick wall. They are free of the internet white, and we have to drain it appropriately and then neatly. We have to provide a block. They easily be the drain. Concrete block can be very in the hardness and drain. Pick can hit the hardened material. So this is for the sandstone. The sandstones are very brittle. We rupture in the correct fastening, fragilized and not utilized. So because when you are drilling the sandstone, very brittle, must be careful. Masonry anchor, the most plus and the anchors need to be the push fish into the drill holes. If the hole is undersized and hammering into the hole can damage the block. So the two large holes, they are difficult to drive the screw. And there's a plastic plus are utilized and they are brightened on the length and the screw ties. So they fully inserted to the end of the plus, so the service expand the greatest. So this is the plastic stuff, plus system. And anchors are color code. They must follow the appropriate figure, and they must see the drill side, screw side. They must be matched, and also for example, 5 is 25 millimeter long plus. The drill side is 5 millimeter, and screw side will be there 3 to 3.5 millimeter. The next system must be followed. We also utilize the fiber plus. They are the old-fashioned, still have a user today. Can be removed or replaced with the number of ties, stand up to the high temperature better than the plastic. This is the ribs of barrel plus are they are really tight fit. They take the range of the screw side. And the soft material, lightweight block, they are the special plus are required. Helical wings are around the barrel is utilized and helical wing grip the side of the hole. When you further into the block, they are very strong and efficient. We need to drain the whole diameter as a plus of barrel, and then the overall diameter plus will be twice the diameter of the barrel. So this is the draining method. So the plus need to be hammered into the wall so that the wings cut into the side of the hole. Now we have to slit the screw through the wall and wall piece then the tightens. So this is the magnet pin anchor. We have to drill the hole to the current dimension, insert the anchor and hammer the nail. So this is how to fix a magnet pin anchor. Now the both methods are inserted. So in this case, method 3 with this method 3 is forced into the side of the hole. So this is what we are create and we can put this is the anchor and anchor wings will be expand. By this way, it can fit the thing. So this is not all the both method inside. So this is include the wing here. First we drill the hole and we insert the anchor and the anchor wing will expand like this. So here will be the drill the holes are equal to the insert diameter. We push into the hole, position the whole wall piece over the threaded. So they put into the washer and the nut and tighten the nut. So this is the. So we also utilize the chemical anchor. The threaded raw with the liquid epoxy, alkylate resin. So this is chemical anger is included present raw with a liquid epoxy and alkylate resin. Liquid chemical become hardened when it mixed to provide the locking the mechanism. They use for the brittle material and the sandstone. We also utilize the powders elevated fastener. They use the explosive powder to force all types on the fastener. They are utilized for the steel and the rod to be fastened to mortar or the switchboard. We also utilize the expanding gas operators setting tool as utilized. In this case, we use the driving fastening element into the wall, steel and plastic, concrete. Use the expanding gas operated electronic control the setting tool utilized. We all use the hardening pins to the wood and the steel and concrete. We also utilize the fiber plus. Fiber plus are the old-fashioned. They still used. They can be removed or replaced with a number of dies. They stand up to the high temperature better than the plastic. Here is a reverse barreling. So this is the really tight fit that take the rain on the screw side. We use a soft material and a lightweight block. They are special plugs are required. Helical wing around the barrel. Helical wing grip the side of the hole and the wing cut the powder into block, giving the very strong fitting. They drill the whole diameter as a plus barrel, and the overall diameter of the plug will be twice the diameter of the barrel. So this is the kind of the MIMS cable and the anchor piece. So this is the diagram. This diagram shows the fishing on the boat, electrical boat. We use the fishing anchor. So this is for the configuration. This is for the button holder, corrugated conduit inspection, PVC, and also the one-way switch. This is for the one-way PVC junction bulb. PVC conduit and metal cylinder. So this is how to fit on the wall. How to fit on the wall, how to fit on the switchboard. So that one is based on here. This is for the rear connection diagram. This is the installation diagram. So we based on the installation diagram this way, and we can really install the board. So here will be the lamp. When you are installing a lamp, so there are lamp connection. So light switch base and lamp holder, conduit, and their dimension connection. Then we also have to utilize the appropriate toolbox that we utilize. So that we have to utilize toolbox, electrogen toolbox must be utilized, switch base, button holder must be utilized. The recognize operational dependent on the material. So this is the kind of the material. This is the measurement equipment. This is the measurements. This is for the screw. Those screws are utilized. Screw. This is a wire plug. And those are the students are the facing the loading installation. So that electrical trade ones I had explained you about the today's workshop prices. For we explain about the different kind of the installation method, also the fishing material we are talking about. Then we continue to do the electrical advanced diploma level. So we continue to do the engineering phases. So Electrical Diploma 2022. Then we look in with the video. YouTube video lesson. Then we continue to talk about the engineering physics. So last week we finished the lesson 5, uniform circular motion. The lessons are you can download from the highlightcomputer.com/video lessons or PDF. So from the page 58 to 86, it includes the engineering physics. So last week we have already talked about the uniform circular motion lesson 5. Today's our lesson 6 we talking about the energy.
Kinetic energy and the potential energy. The kinetic energy is the state of the motion of an object. K equal to half mv squared. In this case, M is the mass velocity, and the mass is the velocity. K is the unit joule. Kinetic energy can be calculated half mv squared. So this problem, and locomotive is a moving at the 2.25 meter per second square. Acceleration and this is weight. What I do to them was 6 Newton. What is the kinetic energy? It moves for 3.2 them was 3 meter. So this locomotive moves initial velocity. You have to calculate initial velocity is 0. This is for the start from 0. We have to calculate final velocity. In this case, acceleration is 0.25 meter per second square. So we calculate the distance of travel 3.2 meter. We write down v square to VO square plus 2AS. V square is VO square is 0 square. 2 multiplied acceleration 8.25 and distance is 2.2 3. So you calculate square for 2.5 multiply 3.2 3. You got 40.8 meter per second. And then that's how we also calculate for the force equal to mg. This is for the force equation. So what I do then was is mass multiplied by 9.8. In this case, mass is equal to 1/2 into 10 kilogram. And then you got the mass, and then we can also calculate kinetic energy. K is equal to half mv squared. Half multiplied 1/2 velocity is 40.8 squared. So you got 2 into 10 joules. And the wall. What W is energy transform for the front and the object by means of the force acting on the object. Energy transform to the object is positive work, and energy transform from the object is the negative work. So this becomes we can write down the force here. This is the angle theta here. This is force. So angle is declination angle is theta. So this is d. So what can also be calculated f cos theta multiplied d. So these are two forces acting on the object. F1 is a 30 when you can and angle 30 degree. F2 is a 10 you can angle 40 degree. Now this is travel 8.5 meter. If you want can be calculated F1 cos theta 1 d1. So F1 is equal to the 12 and cos theta 1 is a 30. This is a 8.5. So equal to 88.33 joule. Square multiplied cos 30 multiplied 8.5. 8.33 joule. In the meantime, you also calculate for the F2. F2 is equal to, if you do is equal to the F2 cos theta 2 d2. So F2 is 10, cos theta 2 cos 40, d2 is 8.5. You got it 3.11 joules. This is the F1 and F2 are adding on the same direction. So the total W is equal to W1 plus W2. So the 88.83 plus 83.11. So the 153 joules. So that this becomes a momentum can also calculate what is equal to similar to kinetic energy can be calculated half mv squared. This problem, a woman can start off the mass 0.4 kilogram, slice across the horizontal pressure less than powder, with speed v is equal to 0.5 meter per second. And then it then runs into and compress a spring of spring constant K equal to 756 Newton meter. Calculate the distance, the spring is compressed. So this one is the spin, this one is moving together. So in this case, the final kinetic energy minus initial kinetic energy, Kf minus Ki can be calculated minus half into K into D squared. So this is the kinetic energy Ke is equal to half mv squared. So in this case, we write down the equation here. So Kf is equal to half into mvs squared, Ki is equal to half into mvi squared, minus half, minus 750 and d squared. So this one is we can substitute. Minor velocity, the L is a 0, initial velocity Vi is already given as 0.5 here. And 750 is a spring constant K and D squared. We don't know the D squared, so we have to calculate D. So in the equations are M can be cancelled. So mass is already given here. Mass is equal to 0.4 kilograms. So from here you can calculate D is equal to 1/2 centimeter. So this one is the potential energy. The potential energy that it is an object above the ground level. So it possesses the potential energy. The potential energy can be calculated mg into h. M is the mass, A is the height, and G is the gravity. Conservation of the mechanical energy. Mechanical energy is K plus U. In this case, E mechanical is a mechanical energy, K is a kinetic energy, U is a potential energy. So E mechanical is equal to K plus U. So this diagram here. So this is original diagram. U1 is a 20. So this is U1 is this one, and this one is a U2. U2 is a 16. U1 is a distance. This one. We have to calculate force for the conservation energy chain. The chain of the energy by chain distance is equal to force. The chain of the energy, the original is a 20. 20 to the 9 will be changed. Original is a 20 because of this one. Original is 20 here. And this is U1 is this is for the 9. 16 minus 7 will be the 9. The time distance change is 1 to 4. 1 to 4. Original is the original will be the 20 here. From the 20 to this is from the 20 to the 9 will be changing. So original U is this set. This is a 20. And final Y is this one. 16 and 7. So 16 and 7 different is 9. The chain of the energy equal to original 20 minus 9. And this die to this die. 1 second to 4 seconds changing, so this becomes 1 minus 4. So the minus 4.3 Newton. So based on the low energy star theory and the example, you have to do the following study. Topic 5 energy, study the slide 1 to 4, do the exercise question 19 to question 23.
And section 7, center of mass. Lesson 7, center of mass.
Center of mass and the linear momentum. So this is the force one is the from the distance h1, force 2 is distance h2, force 3 is from the distance h3. So this is total force total, the distance is hd. So this hd can be calculated f1 h1 plus f2 h2 plus f3 h3 divided by f1 plus f2 plus f3. So we write down the equation. hd is equal to summation fh by summation f. This is for the this H is the center of the F is the center of the mass, H is the time location of the center of the mass. With this problem, 3-party set of the masses M1 is 1/3 kilogram, M2 is 2/5 kilogram, and the M3 3/4 kilogram form and the equilateral triangle of the H 140 centimeter. Find the center of the mass. M1 1/2 and M2 2/5. So this is 140. M3 is 3/4. We write down the equation H to the M1 H1 plus M2 H2 plus M3 H3 divided by M1 plus M2 plus M3. So the M1 is at this here location, so this is the H1 is 0, M1 is 1/2, H1 0, M2 is 2/5, H2 is 140, and M3 is 3/4, this distance. This is the whole thing is at 140, only half will be 70. So this is the we calculate, and then n1 plus n2 plus n3 is 1 by 2 plus 2 by 5 plus 3 by 4 4. So by this way you calculate 83 centimeter. Then y have to calculate this one. In this case, this side is 140, and this side is 70. So we can calculate 140 square minus 70 square. This becomes y equation is 140 square minus 70 square. 140 minus 70 square. So you equal to, so you got the 120. So this is y is 120. So then n1 y1. n1 is located, mass 1 is 1 by 2, y1 is the origin, so this is 0. So mass 2 is also 2 by 5. Body gas are distance is also 0. Mass 3 3 by 4. Body gas distance y is equal to here 120. So we start mass 1 plus mass 2 plus mass 3. Mass 1 and y 1 by 2, and 2 is 2 by 5, and 3 by 4. So we solve, we got the 58 centimeter. With this problem, the figure shows the uniform measurability of the 2R from which a disc of the radius R has been stemmed out. Locate the center of mass. So this is the whole disc is a radius 2R, but this one's a radius 1R is taken out. So we have to find out the center of mass. So we calculate A1, area A1, pi into radius square. Pi multiplied radius is 2R square. And also there's a multiplied with density rho. So pi into 2R the whole square rho, so that pi 4R square into rho. In this case, this is the whole mass 1, h1 is 0 and y1 is 0. And this is mass 2. So area can calculate that pi multiplied radius square, so pi into r square. So this is pi r square. Mass 2 is a2 multiplied rho, so that pi r square into rho. Then we have to calculate h. From this is to left, so the minus r. y2 is equal to 0. So the h total can be calculated from like n1 h1 minus n2 h2 divided by n1 minus n2. So n1 is equal to pi 4 by r square rho, and the h1 is 0 minus pi r square rho. h2 is a minus r divided by pi 4 r square rho minus pi r square rho. So by solving this one now, we got the r by 3. So hd is r by 3. yd n1 y1 minus m2 y2 divided by n1 minus m2. So the ny is a pi 4 r square rho, y is a 0, m2 is a pi r square rho, y2 is 0, and mass 1, mass 2 we already calculated, pi 4 r square rho minus pi r square rho. So this is the yd is 0. So the hd and yd are the position of the center of mass on the display. So that it can be the r by 3 and the 0. Okay, so based on those center of mass theory, you have to do the follow study. Topic 6, center of mass. Study the slide 1 to 6. Do the exercises question 24 to question 26.
This is lesson 7.
Center of.
Now we're talking about the lesson 8 rotation.
Rotation. This is a diagonal rotation. This object moves from the position 1 to position 2. So this is the radius of the rotation is r. So this is the travel through the s. Angle travel is theta. So I is the radius, h is the angular path. So one revolution is taken to the 360 degree, or the 2 by radian. So 1 radian is 1 divided by 2 by or 0 by 1 by 9 revolution. So the angular velocity can be calculated. Angular velocity is omega is equal to delta theta by delta t. So this is the original angle is theta 1, find the angle theta 2. So theta 2 minus theta 1 divided by t2 minus t1. Then we can calculate the angular velocity. So the point that are object moving at the constant angular acceleration, so we can write down the equation. Omega 2 is equal to omega 1 plus F5 delta T. F5 is the angular acceleration radius per second square. Alpha can be calculated. Omega 2 minus omega 1 divided by delta T. Angular displacement is S, can also be calculated. S equal to omega 1 T plus half into alpha T squared. So this is the rotation formula. And based on this formula, we solved this problem. The angular position theta of a reference line on the disk is given by the theta is equal to minus 1 minus 0.60 plus 0.5 squared. A, graph the angular position of the disk versus time. So from the point 3 to 5.4 seconds. B, F what time does theta T reach maximum minimum value? What is the minimum value? Firstly, the theta T is given here. Theta is minus 1 0.60 plus 0.25 T squared. So we substitute the time from the point 3 to 5.4 seconds. So theta minus 3 is we substitute minus 2 here, minus 2 here, 5.4, and horizontally vertical theta, and then all the values are graph. So all the theta and the theta graph. So this is for the theta multiplies the graph. So this is the graph will be like this. And another one is minimum. Minimum is delta T by delta T is equal to 0. 0 means you have to differentiate there. Minus 1 minus 0.6 T plus 0.5 T squared is a differentiate. So what you know is minus 0.6 plus 0.5 T is equal to 0. So from here you can calculate T is equal to 1 by 2 seconds. And then we also can calculate how many angular. In the place of the T is 1 by 2 we substitute here, you got this 1 by 3 is radian of minus 27.9 degrees. So the pi is radian is 180, so the 1 by 3 is radian can be calculated, so this is minus 27.9. And this problem, a grind string rotates at the constant angular acceleration alpha equal to 0.35 radian per second square. At time T is equal to 0. It has an angular velocity omega 0 is minus 4/6 radian per second, and a reference line of it is horizontal at the angular position theta 0 equal to 0. So A, what die after T equal to 0 is the reference line at the angular position theta equal to 5 revolution. B, describe the rotation between T equal to 0 and T equal to 32 seconds. C, F what die T does the grind stone momentarily stop. So that we have to calculate angular initial displacement is theta 0 is 0, and the mode through the 5 revolution. So 5 revolution, theta is equal to 5 revolution. So theta is 5 revolution can be calculated 5 multiplied 2 by radian, so we got it 10 pi. So we can calculate theta here. Theta is omega 0 T plus half into alpha T squared. So theta is 10 by minus 4/6 T plus half into 0.35 T squared. So then we got the 0.175 T squared minus 4/6 T minus 31 by 2 equal to 0. So we compare with the formula A squared plus B plus C equal to 0. A is equal to minus B plus or minus square root of B squared minus 4A by 2A. So in the place of the B we can substitute the minus 4/6 and also this A y175 C minus 31 by 4. So you substitute, so T is at 32 seconds. So then from the T0 to T 32 seconds, alpha is minus 0.35 radian per second square. So this is a rotation at the deceleration. And then the number C, so grind stroke momentarily stop. So that at the times that you can calculate the total omega 0 is at minus 4/6, minus 4/6 radian per second here, and final is the rotation is at 0. So this is final angular velocity 0, so omega equal to 0. We have to calculate the T. In this case, angular acceleration is a 0.35 radian per second square. So that we calculate T is equal to omega minus omega 0 by alpha. So the final velocity 0 minus 4/6 divided by 0.35. For the 13 seconds. So this is the way that we can calculate the grindstones rotation. And then based on the those are the example, we have to do that further study. Topic C, center of mass and linear momentum. Study the slide 7 to 11. Do the exercises questions 27 to question 28. The next topics are relating the linear and the angular variables. So in this case, displacement can be calculated as equal to theta multiplied r. A is a linear displacement, theta is angular displacement, r is a radius. The speed, ds by dt is equal to I into dt by dt. In this case, this is a rotation, so 4 is the adding on the radius r. T is equal to 2 by r by b, or t is equal to 2 by omega. In this case, t is the torque, r by angular acceleration, and also the acceleration dv by dt can be calculated. This is the rt omega by dt. In this case, the tangential acceleration ad is equal to r multiplied alpha, and radial acceleration ai is equal to v square by r, or the omega square r. So this is the linear and angular variables relationship.
And we're talking about the kinetic energy and rotation. Lesson 9.
So this problem, the force rules are right the ring of the rotating merry-go-round. If the angular speed is constant, thus the force rules are have is a radius acceleration, increase the tangential acceleration, what angle theta b should the arc substance so that the A is the pole at the point B. So this is for the rotation here. So in this case, we can calculate tangential acceleration the dv by dt or r into d omega by dt. So that we assume that the angular speed constant. So in this case, d omega by dt is 0. The ad is r into the d omega by dt. So the r multiplied 0 is equal to 0. So this is the loss of tangential acceleration because the ad is equal to 0. AR has to be calculated. AR is the omega square r. It has a radial acceleration. So that because of this one called the constant radial acceleration, we use the formula omega square equal to omega 0 square plus 2 alpha into theta minus theta 0. In this case, the alpha is ad by r, omega 0 is 0, theta 0 is 0. So we write down the equation. Therefore, the omega square is equal to 2 alpha theta. But alpha is ad by r, so therefore the omega square is equal to 2 ad by r into theta. So the AI is equal to omega square r, so omega square is AR by r. So AR by r can be calculated 2 ad by r into theta. Therefore, there's a 2 ad by r into theta. In this case, we write down the equation. AI is a 2 ad theta. So A is a total acceleration, tangential and the radius are combination. So a square root of ad square plus ar square. Therefore, A is equal to square root of ad square. But AR is you can substitute 2 ad by theta by square. So this is for this one you substitute it. I can say AI is equal to 2 ad theta. Substitute. Therefore, by solving this one, what you got is the way is 2 ad theta is equal to square root of a square minus ad square. Divided by 2 ad, so what you got the theta equal to half into square root of a square by ad square minus 1. So in this problem, so this is the we calculated. We calculate the angle theta. So in this problem, A is equal to 4G. So you substitute in the place of the A, you substitute 4G, AD is a G. So we substitute the theta D, we got the 1.94 radian or 111 degrees. The next one is the kinetic energy of the rotation. So those are the mass M1, M2, M3 are revolving at the B1, B2, B3. So in this case, the kinetic energy can be also calculated half into M1, B1 square plus half into M2, B2 square plus half into M3, B3 square. In this case, the rotation energy R is a summation of mi into ri square or the half I into omega square. So the I can be calculated rotational inertia, integration of r square dn. So this is the dn, this is the moving, the cross the radius r. So that depend on the side. This is a circular shape, and this is for the cloud, this is straight, this is the hollow. We can calculate their rotational inertia by the law formula. Torque is this is the force, this is the AC. The force is moving around the R, so this is the torque. Torque can be calculated as 4 multiplied this step. Torque is F multiplied R or I multiplied alpha. I is the inertia, alpha is the angular acceleration, F is the 4, I is the radius. Torque equal to mr square alpha. So this problem is the might is the N1 going down. This is density. So this is torque D. Torque D multiplied R, so we can calculate. So the figure show the you divide this with the mass and the divided by kilogram R 20 centimeters. Firstly, we calculate T is equal to M into R. T minus M is equal to MA. So that A is equal to T minus MG by M. So MR minus MG by M. MR is at 2.5. I is at 20 centimeter, 20 by 100. MG is at M is at 1 by 2. G is 9 by 8. Divided by 1 by 2. So you got that minus 9 by 39 meter per second square. So based on the whole linear and the angles are available, so we have to study slide 1 to 10, do the question 29 to question 30. The next one is a torque and the equilibrium. The torque is a rotation with the this is the R. Omega is the angular velocity. V is the linear velocity. So V can be calculated omega multiplied R. Kinetic energy K is half into I omega square. In this case, I is the moment of inertia. Omega is the angular velocity, radian per second. So those equations are this is for this bracket R. Moment of inertia is I into M into R square. M is the mass. And this rate, this is the net L. So that I into half 12 by 1 by 12 ml square. And this follow internal radii R2, external radii R1. In this case, I equal to half M, R1 square plus R2 square. And this is straight. The distance A and B, so that I equal to half M, A square plus B square.
Then we're talking about the equilibrium. Lesson 10 equilibrium.
So this problem, a rolling object has a linear velocity 342 by 5 meter per second. Radii is 3 meter, mass 170 kg. You have to calculate the kinetic energy. So this radii is 3 meter, mass is 170. So K is equal to half into I omega square plus half into MV square. So in this case, I is equal to half into MR square, and omega is V by R square, half into MV square. So by solving this one, what you call is a half MV square plus half MV square. 1 for MV square half MV square to 3 by 4 MV square. Then the mass is 170, velocity is 42 by 5. We substitute, so you got the thing is 1.5 into 10 power 7 joule. Equilibrium. The linear momentum P is a constant at the time of the equilibrium. This is the equilibrium. The object is not moving horizontally or vertically or rotation. No rotation, no horizontal movement, no vertical movement. This is the equilibrium. In this case, linear momentum P is a constant, angular momentum A is also the constant. Rate of change of P is 0, this is the equilibrium. dP by dt 0, net force dP by dt also 0. So there. In this case, summation F is 0, summation F by 0, and D net. So this is the net of torque also the 0. So this problem, the figure shows the overview of the uniform draw in the static equilibrium by the magnitude of unifying force. So this is for this case here, 10 Newton going down, this is F1 at the A, 13 Newton. So this is F2. This is 20 Newton, so this is 4 meter, 2 meter, 1 meter, 1 meter. So in this case, at the A, to the torque is 0. So in this case, S is this way, F2 rotates in the crosswise, F2, the distance is 1 plus 1. And this one is 10 rotates in the crosswise. 10 multiplying distance is 2. Equal to, so this one is the clockwise position. Clockwise position is 30 Newton multiply 1, and this 20 Newton in this distance 6, 4 plus 2, this is the clockwise. In the clockwise equal to clockwise, then you got the F2 65 Newton. Then the vertical moments are 0, summation F1 0. All the outward forces are equal to all downward forces. The outward forces are 20 plus F2. And downward force are 10 plus F1 plus 30. So in this case, we already know that F1 is 65, so use F1 is equal to 65, F2 is equal to 65, so we calculate F1 equal to 45 Newton. The next one is gravitation. So this is for this momentum here. This is the equilibrium. The rotation is 0, F1 0, F8 0. So that in this case, F1, F2 are outward, F3 to outward, so that F1 plus F2 equal to F3. The next one is gravitation. Mass 1 and mass 2 they are separated by the distance R. The force between 2 is F1, F12 equal to G into N1, M2 by R square. In this case, G is equal to 6 by 67 into 10 power minus 11 meter cube by kilogram second square.
We're talking about the fluid.
Fluid is a common substance that can flow. Density can be calculated multiplied by volume. Density for the air is 1/2 kilogram per meter cube. Water at the 20 degrees centigrade 50 atm is 1 into 10 power 3. Iron is 7.9 into 10 power 3. So pressure is the force divided by area. The force here and this is the area. So force divided by area. So F divided by A is the pressure. So in this case F equal to mg equal to the mg by A. For the 1 unit area A is equal to 1. So the unit pressure equal to the mg. Mass can be calculated. Mass is the density multiplied volume. So the m is equal to rho multiplied v. And rho is density, v is the volume. Unit pressure is the rho v multiplied with g. With this problem, the living room has the flow dimension and the height of the 24 meter. What does the air in the room weigh when the air pressure is 1 atm? What is the magnitude of the atmosphere's power force on the top of your head, which we should take to have the 0.04 meter squared? In this case, the air force can be calculated. FA is equal to rho v and rho g. Rho is a 1/2 kilogram per meter cube. Volume is this is the air dimension 3.5 multiplied 4.2, and the height is 24. So 2.4 meter. This is multiplied. And also the G is the 9.8, so equal to 420 meters. And then 4 is equal to pressure multiplied area. Pressure is 1 atm. So 1 atm converted to the kilogram meter square, so 1.01 to 10 power 3 divided by 1 atm. And this is for the 0.04 meter square. So because it's 4,000 meters. The fluid pressure at the depth H. This is at the depth H, this is the fluid pressure. So fluid pressure is PV. At the H, this is the density is rho 2. P2 is equal to P0 plus rho GH. So that this problem, the U2 in the theta in the statistics are equal to the density of water is rho 2 is 998 kilogram per meter cube. A is 135 millimeter, D is 12.3 millimeter. This is U2 here. D is 12.3, A is 125 millimeter. So this is the Y, this is for the air and the water. So the Y pressure is the tower, and the water pressure is the hour. So Y pressure equal to air and the water pressure. So here we need to find the density. So the Y pressure equal to the water plus air pressure. So then this is for the interface Y. P interface is equal to P2 plus P0. So the P interface is equal to the water pressure is the rho into G, air plus D, and air pressure is PA. And therefore the Y density can be calculated. This is the equation. So rho A is equal to rho 2 multiplied air by air plus D. Rho W is 1, A is 135, D is 12.3. So you calculate, so 915 kilogram per meter cube. So the barometer we can measure the air pressure. Air pressure is rho multiplied G multiplied H. So is the density, G is the gravity, A is the height. And Pascal principle. So this is for the two cylinder here. F1 put on the area A1. F2 and the area A2. So pressure P1 equal to pressure P2. P1 equal to P2. Therefore, the F1 by A1 equal to F2 by A2. And the mass remote the equal amount of the fluid. The Archimedes principle. When a body is fully or partially submerged in the fluid, a buoyant force F2 from the surroundings of fluid S on the body. And force is directed toward M, has a magnitude equal to the weight, the energy of the fluid that has been displaced by the body. In this case, this is the weight here, weight is submerged into the water. This is the apparent weight. So F is the buoyant force outward. So the apparent weight is equal to equal 4 minus magnitude of the buoyant force. So this is for the Archimedes equation. In the midline of Bernoulli's equations are water is flowing here from one point to another point. When the fluid is flowing through the force of pressure, gravity, height, and the velocity is the same. So P1 plus half into rho P1 square plus rho GH1 equal to P2 plus half into rho P2 square into rho GH2. P1 is the pressure. This is for the V1 velocity is the gravity height. So these problems are the diagram show the stream of the water. Imagine flowing the force sets are net. So A0 is 1/2 centimeter square. E is 0.5 1.35 centimeter square is 45 millimeter. You have to find the volume. So this is the volume you have to calculate. So this is the volume. V0 is square root delta. RB so A0 is V0. V square is the V0 square plus 2GH. So V0 is equal to the square root of 2GH A square. A0 minus A square. So 2 is at 9.81. A is at 135 square. So A0 is 1 by 2 square and a 0.35 square. So you got a 0.216.